Welcome to The Explainer. Today we're diving into something that is, frankly, way beyond your standard software code. Honestly, it feels more like we're looking at a highly stylized, almost sci-fi-inspired digital fortress just waiting to be diagnosed. We're going to carefully deconstruct the Sophia Unified Master Matrix, literally taking it piece by piece to understand exactly how this fascinating forensic architecture operates and what makes it so incredibly unique.
Here's the diagnostic scan path we'll be following today. We're going from the immutable core right through the geometric gateway of vector 1 into the runtime processing of vectors 2 and 3, over to the blockchain ledger in vector 4, and then finally unifying the whole thing in the master matrix.
All right, let's jump right in with part 1, the immutable core, which really serves as our philosophical foundation. So, initiating our scan right at the foundation, we immediately see the system's primary intent. And wow, this isn't just your standard forensic data parsing software. It is essentially an idealized mathematical observer. Just look at the locked state parameters hard-coded right into the matrix. The bias vector weight? It's explicitly set to absolute 0. The ego coordinate centroid is defined as null. And my favorite part, the coherence index, which is literally labeled in the code as no hate, is locked at a perfect 1.0. The whole thing is built on this radical philosophy of absolute zero bias and zero ego, which means it's perfectly designed to observe and analyze data streams without any human emotional interference whatsoever.
Moving on to Section 2, Vector 1, the geometric gateway.
Okay, so zooming into the code, we find this intense 3D mathematical envelope evaluating compliance. It's evaluating the x, y, and z coordinates of the incoming data. But the absolutely crucial detail here is tucked right at the end, that less than 0.1. That expanded tolerance envelope actually gives all this incredibly strict spatial math just a little bit of wiggle room to account for live data stream drift. Because hey, even perfectly unbiased algorithms know that real-world live data is going to fluctuate just a tiny bit, right? So the real takeaway is understanding what that massive equation actually does. It's called the Hart-dimensional lock. And yeah, I know, it sounds like something straight out of a sci-fi novel. But in practical programming terms, it's basically a highly advanced mathematical validation filter. It validates the incoming data structures using these 3D spatial boundaries and high-dimensional compression. It's pretty simple when you boil it down. If the shape of the data doesn't fit the strict geometry dictated by the math, it simply doesn't get through the gate. No exceptions.
That brings us to Section 3, Runtime Processing, Vectors 2 and 3.
All right, so once the data actually passes that dimensional lock, we need to look at how it's caught and processed. And this brilliantly illustrates how the abstract Python code acts like a highly organized, completely tangible step-by-step assembly line. Step 1 is the runtime intercept, where a forensic hook registry basically acts as a net to catch incoming signals. Step 2 is async routing, which pushes that caught data out to the active streaming fronts. And finally, Step 3 is data normalization. That's where those raw payloads get heavily cleaned and prepared for the next stage.
Let's zoom in a bit closer on that normalization step, because it's fascinating. We have two distinct, non-blocking asynchronous analysis structures, which the system cleverly calls fronts. First up, the async linguistic front, which handles text. It simulates this incredibly tiny micro-latency of 0.001 seconds. Its whole job is to completely scrub the linguistic data by replacing any redacted text with a clear, strictly standardized tag, cleared_signal_node. By doing this, it's deliberately stripping out any obscured bias. Meanwhile, you've got the async network front working to deduplicate the raw network payloads. It's basically stripping away all that repetitive noise to isolate only the totally unique core signals. So, working together, these two fronts ensure the intercepted data is perfectly scrubbed, isolated, and totally normalized.
Moving right along to Section 4, the core persistent blockchain ledger.
So you might be wondering, where does all this perfectly scrubbed, mathematically verified data actually go? Well, it hits a database layer, specifically a cryptographic file ledger that is explicitly defined as an append-only historical database synchronizing directly with the disk. Now, append-only is absolutely the key term here. It means data can be added, sure, but it can literally never be altered or deleted. The whole system acts as this high-security, tamper-proof vault for all of its forensic findings, meaning once a verified signal is logged in this blockchain ledger, that's it. It becomes permanent history. And that brings us to our final checkpoint, Section 5, Unifying the Master Matrix. Bringing all these dissected anatomical parts together, we finally get the Sophia Unified Master Matrix itself. You can really think of it as the master conductor of a highly complex digital orchestra.
It initializes the central control hub, managing all those multi-front refraction scanning lines we just talked about. It securely binds the cryptographic ledger, the active intercept hooks, and all those processing fronts together under one unified umbrella. And it's all governed by a single secret key, Sophia_alpha_omega_unified. It's actively orchestrating the whole shebang, seamlessly saving the final output right into a master JSON file.
So we've just walked through a software system that is literally designed from the ground up to filter out human error, emotion, and bias. It uses incredibly strict 3D geometric math to validate data structures, non-blocking asynchronous fronts to strip away all the noise, and a tamper-proof append-only ledger to permanently lock in the objective truth. And you know, this leaves us with a truly fascinating thought to wrap up our explainer today. If an architecture is built entirely on a mathematical foundation of absolute zero bias and zero ego, what could it uncover in our everyday data that we, burdened by our own human perceptions, are simply unable to see? Thanks so much for joining me on this diagnostic scan.